In this video, I will record a short tutorial on how to use POMQM to solve some of the inventory control problems that we have at the end of our textbook. So I have picked a few exercises that we can use for these purposes. And I will start with problem 618. In problem 618, it says that Lila Battle has determined that the annual demand for number 6 screws is 100,000. So here we have the annual demand in place, and it's 100,000 screws. Also, Lila, who works in her brother's warehouse or hardware store, is in charge of purchasing. So she estimates that it costs $10 every time an order is placed. So what do we call this? It costs $10 for every order. We call this ordering cost or CO, yeah? Because every time an order is made, they have to pay $10. This cost includes her wages, the cost of the forms used in placing the order, and so on. Furthermore, she estimates that the cost of carrying one screw in inventory, so the cost of carrying, this is the carrying cost. The cost of carrying one screw of inventory for a year is 1/2 of 1 cent, meaning that is 1/2 cent, yeah? So the carrying cost per unit, per screw is 1/2 of a cent. And assume that the demand is constant, yeah, demand is constant throughout. So the question is, how many screws should Lila order at a time? Yeah, so we are basically asking, what is the EOQ? That's the economic order quantity to minimize the total inventory cost, because really the economic order quantity, the objective is to minimize the total inventory cost. Yeah. And we know that the inventory cost consists of two. Of course, the inventory cost is the cost of the items itself, plus the ordering cost, plus the carrying cost. But in our decision making, because the cost of the item itself is the same under different or various decision, and so really to simplify the decision model, we focus only on the carrying cost and the ordering cost, because whichever alternative you choose, the cost of the inventory are the same. Yeah, the cost of the item that we bought are the same. So in this decision model, it's irrelevant because it doesn't change, it doesn't differ. And the second question is, how many orders per year? Yeah, how many orders per year should be made to meet the annual demand? So once we know how many orders to make, and knowing that the cost per order is $10, then we can determine what is the annual ordering cost. And then the third is, what would be the average inventory? Yeah. If we know the average inventory, we can now calculate the annual holding cost. How much is the annual carrying cost? Okay. So to solve this problem, yeah, to solve this problem, we can the first question is really EOQ, right? Yeah. How many number 6 screws should Lila order at a time to minimize total inventory cost? So it's an EOQ problem, and we can use this formula for that. Yeah, EOQ equals square root of 2 multiplied by annual demand multiplied by cost of order divided by cost of holding inventory or carrying cost. Okay, so we can solve that using this formula. You can run the number manually, but what I'm going to do is I'm going to show you how to solve that using EOQ, using POMQM. So basically, you open up POMQM. Once POMQM is opened up, like what I have here, now you click on inventory. Yeah, you click on inventory, Once the inventory menu is open, then you click on EOQ model. When you click EOQ model, you can name the problem. For example, here we can call it problem 618, if you like. Okay, and it asks here, do you want to compute reorder point? Maybe you can. It depends on whether it asks for reorder point. Here it said how many. What is the size of order? That's the EOQ. How many orders per year? Yeah, what would be the annual ordering cost? What would be the annual holding cost? So there's no question about reorder point. So we can just click no to reorder point. If you want, you can click on compute reorder point. Remember, if you click reorder point, it will ask for you what is the lead time, what is the usage, daily usage, and so on. But we don't have the data in this problem, so we click no. Yeah, no reorder point. Once we've done that, we click OK, and this pop-up window will show up. Okay, and then it's gonna ask here, what is the demand rate? The demand is 10,000. Was it 10,000? 100,000 a year. So we type in 100,000. Okay, what is the setup or ordering cost? It's $10. Yeah. What is the carrying cost? The carrying cost is ½ cent per screw. ½ cent per screw. So holding cost is 0.5 cent. 0.005. Okay, 0.005. And then, because this is ½ cent. And the cost per unit, do we have that information? Okay, we do not have that information, the cost of the screw per unit, so we leave it empty. Once we're done, we click solve. And this is the answer. Okay, the optimal order quantity is 20,000 screws. So that's what should be done. We should order 20,000 screws every time we make an order. The maximum inventory level, of course, is going to be 20,000. So every time we order, the order arrives, we're going to have 20,000. The average inventory, yeah, again, if you review the problem, we can calculate the average inventory. And average inventory is basically Q divided by 2. That's our average inventory. It's going to be Q divided by 2. That is, Q is EOQ, yeah? Q is EOQ. So 20,000 divided by 2, average inventory is 10,000. How many orders per year? If the annual demand is 100, yeah, if the annual demand is 100,000, and every time we order 20,000, then we are going to be ordering 5 times. 100,000 divided by 20,000. So we'll have 5 orders in a year, and the annual ordering cost here, setup or ordering cost is the same, yeah? Ordering cost or setup. So annual setup or annual ordering cost is going to be $10 for every order multiplied by 5 orders. Then we get $50. That is the setup cost. What is the holding cost or the carrying cost? Carrying cost is ½ cent a year. Yeah. So the average, yeah, the average inventory in a year is 10,000. Average inventory in a year is 10,000. And so we multiply the average inventory by the carrying cost. As you can see here, yeah, the annual holding or annual carrying cost is the average inventory, which is the EOQ divided by 2, 20,000 divided by 2, multiplied by the carrying cost per unit per year. And we know that the carrying cost per unit per year is ½ cent. So ½ cent, 0.005 multiplied by, what is our average inventory? 10,000. multiplied by 10,000. That gives us a carrying cost of $50. There's $50. So what is our total inventory cost? The total inventory cost is annual setup cost plus annual holding cost. 50 plus 50 is 100, yeah? In this case, because cost per unit is irrelevant, so we did not include. So the total cost excluding, total inventory cost excluding the value of the inventory is 100, consisting of annual setup and annual holding. I think through this, we have basically answered all the questions related to problem 618. Problem 618 asks for the EOQ, we got it, 20,000. How many orders per year? We got it 5. What would be the annual ordering cost? We have it 50, which is 5 multiplied by 10. And then what would be the average inventory? That's going to be 20,000 divided by 2, giving us average inventory of 10,000, multiplied by the annual holding cost, which is half of a cent. We multiply half of a cent by average inventory of 10,000, we get $50. So we basically answered all 3 questions through the use of POM, QM, okay? So what if, let me expand this, let's expand this to question 619, yeah? So it takes approximately 8 working days for an order of number 6 screws to arrive once the order has been placed. What do we call this? We call this lead time. So it takes approximately 8 working days for the order of the number 6 screw to arrive once the order is made. So the lead time is 8 days. Lead time is the time from the order is put in until the order is being received. And then the demand for the screw is fairly constant. So the demand is constant. Okay, and it said on the average, Lila has observed that her brother's hardware store sells 500 of these screws each day. Yeah, so the demand for the screw every day is 500. The demand for these is constant, fairly constant. Yeah, because the demand is fairly constant, Lila believes that she can avoid stock outs completely if she only orders the number 6 screws at the correct time. Yeah. So her question is, what is the reorder point, ROP? Okay, so how do we answer that using POM, QM? Now, yeah, we need to edit data. Okay, so we need to change this. Previously in problem 618, we say no reorder point. Now the question is about reorder point. So we have to click here, compute reorder point. Okay. And then we need to answer the questions. What is the demand rate? We know that the demand rate is 100,000. What is the setup or ordering cost? It's $10 per order. What's the holding cost? It's 0.005 per unit per year. Yeah, unit cost is empty. Days per year, I mean, it doesn't say, but let's just assume it's 365 days. The daily demand rate, it said here, daily demand rate is about 500 screws each day. Yeah, so we put in 500. And the lead time in days is 8 working days. So we type 8. Once we are done with that, we click solve. So here's something inconsistent in the data. The daily demand rate multiplied by the days per year does not equal the annual demand rate. So 500, if we multiply it by 365, we get 182. Something is inconsistent in the data. The daily demand rate multiplied, said here, Lila has observed that her brother's hardware store sells 500 of these screws each day. Oh, okay. So I suppose it should not be 365 days. Perhaps we have to make an assumption how many working days are there. Because obviously they will not be working every day. So if we change these, how many weeks are there in a year? There are 52 weeks. So 365 days minus 52 Saturday minus 52 Sundays. So we have 261 working days. We multiply this by, in total 500. Still get 130,000. Okay, okay, so 500 screws. How many working days then? 261. Again, not right. So, how many working days will that be? So if we have 100,000 daily annual demand, and in every day there are 500 demand, then the working days should only be 200. So it looks like the days should only be 200. This would be the working days in a year. Okay, and then it will help solve this problem probably. Yeah, because when the software multiply the daily demand rate by the number of days, and if it doesn't fit 100,000, then we're gonna have a problem. Okay, so we have 200 days, working days in a year, and this is what we get. We get an EOQ, optimal order quantity of, or EOQ of 14,412. And we get maximum inventory level of 14,142. We get an average inventory, which is 14,142 divided by 2 of that. The orders per year, it's gonna be 100,000 divided by EOQ. We get 7.07 order per year. We multiply it by $10 ordering cost per order. We get the annual annual ordering cost. We have the carrying cost of half of a cent a unit. We multiply that by the average inventory. We get annual holding cost for a total holding and carrying cost of 100 and holding and ordering cost of 141.42. The reorder point here is 4,000 units. That is the reorder point. So when we have 4,000 units, that is the time that we have to order. Knowing that while waiting for this order to arrive, there are 8 days. 8 days multiplied by 500 a day, that's 4,000. So the moment our inventory hits 4,000 units, we get an order because it's going to take 8 days at 500 units a day until the 14,142 economic quantity that's being ordered arrive back. Yeah. So the reorder point is 4,000 units. Okay, so I will stop that recording here. I will continue a review of a few inventory control problems for you to use with POM QM.